All right, for the first one, Cole, DeLuca, what'd you get?
I got the natural log of x cubed plus 3x squared over the square root of x squared plus 3.
All right, x cubed plus, what'd you say?
3x squared.
Like that?
Yeah.
Over?
The square root of x squared plus 3.
Oh, all right, you do not, what?
That's supposed to be 5. So.
5 plus 5. Okay, you do not need to distribute on top.
Okay.
And I think you did that wrong. Anyway, so take a look at that. All right, so your first step here. And that's 1/2 is going to be the square root. I agree with that, and that's going to be x squared. So I'm just going to take a little bit of liberties here. That's x squared over the square root of x squared plus 5, plus the natural log of x plus 3 cubed. Cole, you agree with that?
Yeah. All
right, now what's going on here? Since you got that x plus 3 cubed, technically you would have to cube that whole thing, which we don't want to mess with that. And then don't worry about doing that later. Now, these two do multiply together, and that should go in the numerator, but I'm going to get x squared times x plus 3 quantity cubed over the square root of x squared plus 5. Okay. Agree? All right, so that should be that case. And like I said, do not, and now you can't distribute it the way it is here, and then don't take that to the third power. Just leave it in that simplified form. All right, how about the second one? Mackenzie Ward, what do you think?
I got 3 log x plus 1/2 log z.
Hold on.
Oh, sorry.
Plus 1/2 log z.
Minus 2 log y.
Minus 2 log y. Oh, I agree. We agree? Okay, so make sure that log of the numerator minus the log of the denominator, and then the log of the numerator can be split, and then you got to take care of all those powers. So that would be correct. So I just wanted to hit a couple more there. Make sure we're good on those. All right, homework-wise, the only even one was 16, but double check 125. You need to make sure that you got those right. So I put those up there again as well. So look through those. I'm going to collect up your quizzes. If you got any questions on your quizzes, now is the time to ask. Yours is graded online. So.
What's your name?
It was different than usual.
Thank you. Yeah. Thank you.
Yep.
All right, any question on 125? Any of those that maybe you're not quite positive about, or why they have those? Okay. All right, we're gonna finish up those notes from yesterday, and then we're gonna hit starting section 4.4. Okay, and then we'll get to part of that, and then we'll finish that tomorrow, review a little bit on Monday, and then we'll take our test, our second, the Unit 4 test, Tuesday, Wednesday. I haven't heard from anybody, so I'm assuming everybody plans on being here. If there's a family issue, let me know. I know there's probably a lot less this year. All right, this is your exponential growth formula. We've had this before. K is your rate of growth, rate of decay. T is the time. All right, so take a look at this case here. In an experiment, 18 grams of the radioactive element sodium 24 decayed to 6 grams in 24 hours. Find its half-life to the nearest hour. Well, half-life means, when is half of it left? Okay, for that hour, or to the nearest hour in this case. All right, but we've given enough information. You're going to have to find K. You're going to have to find K. And I'm going to tell you, we're going to keep it in its exact form. I'm not going to round it off at this point. Well, take a look at that formula. A of T equals A of 0 e to the KT. And now we were given that it has started with 18 grams, and after 24 hours, it had 6 grams. So, all right, let's put all that in and see what's missing. Well, what will go in for A of 0? A of 0 is your original amount, which is 18. After 24 hours, there's 6 grams left. So put that 6 over there. Oh, we need some. You weren't here. Here you go. These were yesterday. 2 pages. And we are on right there. 18. E, we don't know what K is, but for this case here is 24 hours. Divide by 18, and just make that 1/3. Equals e to the 24K. Make that 1/3. All right, now, remember what we do. This is where we convert to natural log form. Okay, when you got e to a power equals something, we convert to natural log form. So that is going to be the natural log of 1/3 equals 24K. And so K is the natural log of 1/3 divided by 24. And it's going to be some decimal. Just leave it like that. Leave it in that form. Okay, we're not round anything off. We're going to keep it in the exact form. All right, now use that to determine its half-life. Well, for the half-life, we just want to know when there's 9 grams left of the original 18. And so you're going to divide by 18, and we get 1/2 equals e to the KT. Do that same concept, take the natural log or convert it to natural log form. Natural log of 1/2 will equal KT. Divide by K. And then this is where I'm going to plug in that K value. So T equals the natural log of 1/2 over K, which is the natural log of 1/3 divided by 24. All right, just be careful. Plug that into your calculator, see what you get. Maggie Purdy, what'd you get?
0.0317.
Oh, we got something wrong there. Should be 15. So that was it at the end. Natural log of 1/2. What do you got there?
Oh, I didn't divide.
Yeah, you didn't want to divide it for some reason. Okay. Aaron, what'd you get?
15 hours.
You get 15. Yeah, around like 15.1 or something like that, right? So it said nearest hour, so we're going to go 15.1. Or excuse me, just 15. All right, so you get 15 hours for that one. That's and just kind of making sense here. If it decayed from 18 to 6 in 24 hours, it's got to be less than 24. Okay, so just common sense wise. All right, looking at that half-life formula. Now we can go through and figure out the half-life that way based upon what we're given, but then there's a little bit of a formula here if you know what K is in this case. So it says H equals negative natural log of 2 over K. All right, what we did before is, and I just want to show you this. So we had A equals A sub 0 e to the KT. All right, to find the half-life, I'm going to let this be H. And then it doesn't matter what I start out with my original, what happens to A? It's going to be cut in half. So if this is 12, this is 6. If this is 20, this is 10. If that's 100, it's 50. So what happens when you divide? You're going to get 1/2 equals e to the K. And then I'm going to let that H represent the half-life. Convert that to ln form. What's that going to look like? It's going to say ln of 1/2 equals K times H. And now that gives me H equals natural log of 1/2 divided by K. All right, why are those the same? I want you to take a look at that. Why are those the same? Because we just did that. You got to agree with that's natural log of 1/2 divided by K, but they give you this little different formula, negative natural log, or natural log of 2 divided by K with the negative out in front. Okay, we're going to make the claim, or I'm going to tell you that the natural log of 1/2 is equivalent to negative natural log of 2. Now why? Why is that going to be the case, or how can we verify that? Or am I just crazy?
Would it have something to do with raising 2 to the negative first power would give you 1/2?
You can do that either way. So this is a constant out in front, a negative. You can treat that as a -1. So if you got a -1, what can you do with a power in front of a log? You can make it a power. So I can make this natural log of 2 to the -1. Well, what's 2 to the -1? That is 1/2. Or I could start with 1/2. And can't you make 1/2? Isn't that the same as 2 to the -1? So I can make this 1/2 2 to the -1. And now the -1 can go out in front. But either way, natural log of 1/2 is the same as negative natural log of 2. Now they've chosen, and this is out of the book, they've chosen to use negative natural log of 2, maybe because it's a little bit nicer than using the fraction. But those are equivalent. Bless you. Okay, those are equivalent. All right, now take a look at that bottom one. It says plutonium-241 has a half-life of 13 years. If you originally had 80 grams, how much would remain after 18 years? All right. So what you can do is you can find, we need to know the K value. You can go the long route and find the K, or you can use that little formula where it says H equals negative natural log of 2 over K, and just rewrite this, and then this will be flip the K and the H. K will equal negative natural log of 2 over H. Well, what is our half-life in this case? They already tell us it's going to be 13. So K equals negative natural log of 2 over 13. Now go back to your original formula. So A equals A sub 0 e to the KT. Now we want to know when there's, if you originally had 80 grams, how much would remain after 18 years? So you would have 80 e to the K, which is negative natural log of 2 over 13, times T, which is 18 years. I think nearest tenth is sufficient. Go ahead and see what you get for that. Yeah, I don't know which way it makes it there. Yeah, what'd you end up with?
3.1 times 10 to the negative 1.
Oh, we got a problem.
And I think if I can make it very long.
All right. Gee, we give you a little flame file. Yeah. Oh, okay. That's right. Tony, what'd you get?
30.6.
30.6. All right, I agree with that. 30.6 grams. So just kind of understanding that if this half-life is 18 years, or excuse me, the half-life is 13 years. After 13 years, you can only have 40 grams left. You're not going to hit another half-life, so it has to be in somewhere between 20 and 40 for that one. All right, we're going to move into section 4.4. You can do it on the back. You can do it on a separate sheet, wherever you need to, but this is kind of some different stuff here. Solving exponential equations. And then we will hit log equations tomorrow. All right, copy that first one down. All right, the first thing you want to do, now your only directions here are round to 3 decimal places if needed. All right, the first thing you want to try to do is, can you make these equivalent bases at this point? And that's what the first thing you want to try when you got an exponent that's a variable. So 9 can be rewritten as 3 squared, and 27 can be written as 3 to the 3rd power. So that's what I mean by equivalent bases. So replace the 9 with 3 squared. That is still to the x minus 2. Replace the 27 with 3 cubed. All right, so that's our first goal. Can we rewrite it same base? Well, you got to do a little bit of simplifying here. So 3 squared to the x minus 2, you got to multiply exponents, which would be 2 in the x minus 2, basically distributed it. So that gives me 3 to the 2x minus 4 equals 3 cubed. All right, once you're there, you got the same base. They're equal. All you got to do is set the exponents equal to each other. So to solve this, 2x minus 4 has to equal 3. So 2x minus 4 equals 3. Add 4. 2x equals 7. X equals 7 halves. Okay, for those. So take a look. Can I get the same base? All right. Try number 2. Try and get it the same base. You're stuck. I'll go over here in a second. But think about what you would do here. All right, Luke, how can I rewrite 8?
You can take 2 to the 3rd power.
Okay, and how about the 16?
2 to the 4th power.
All right, good. 16 is 2 to the 4th power. All right, x. Now, that 3 will distribute, so you get 2 to the 3x minus 9, and that's 2 to the 4x. Now, 3x minus 9 equals 4x. Subtract 3x. Subtract 3x. And then I get negative 9 equals x. Or x equals negative 9. All right. So find the same base. That doesn't always work. So this one here, so what if I have 4 to the x power, that's the x power, equals 100. 4 to the x power equals 100. Try to get to the same base. You can't. 4 is 2 squared. 10 is not 2 to a power. 10 is 10 squared, or excuse me, 100 is 10 squared, but you cannot rewrite it. So you can't do the same base. This is where we use logs. Okay. First two, we could get the same base, we were fine. Now 40, we're stuck. Take the log of both sides. Okay. Now it can be any base, but the two you're going to typically use are your common log and your natural log. So make this log of 4 to the x equals log of 100. Okay, log. Now, here's why it works, because what can we do with the x? Since it's an exponent, we can move it out in front and make it a constant. So now this becomes x times the log of 4. X times the log of 4 equals log of 100. Now, log of 4 is a number. Divide by log of 4. Divide by log of 4. And x equals, whatever you get, 3 decimal places. You're not going to get a whole number here. Now, it's got to be between, because 4 squared is 16, 4 cubed is 64. 4 to the 4th power, what is that? 2 something. So it's got to be between 3 and 4. What'd you get, Josh? Wait, let everybody do your work. Cooper, what'd you get?
3.322.
3.322. All right, so that makes sense. 3.322. All right, question here. Log. Okay, now you can also do, like I said, you can also do the natural log. Of 100 divided by the natural log of 4. And now you should get the same thing. All right, question. Is the natural log, or excuse me, is the log of 100 divided by the log of 4 the same as the log of 25? True or false? Ryan says true. Ryan says true. Ryan's wrong. Don't listen to Ryan. Okay. Don't listen. You must not have really worked hard on those true false questions. So log of 25. Okay, is not 3.322. Okay. Now you got to remember, what would be log of 25 if you had log of 100 minus log of 4? That would equal log of 25. So this is a case, and I see it all the time because it's just your mind just takes over and you think, oh yeah, I can divide those. No, you cannot. Log of 100 divided by log of 4 it does not equal the log of 25. Okay, that goes back to, that would be the case when you have log of 100 minus log of 4. So just be careful on that. So that does not equal the log of 25. Now this is as basic as it can come. That just demonstrates the procedure. Now let's take a look at something that's probably a little more complicated. I'll call that number 4. All right, 8 times 3 to the x minus 2 equals 20. All right, what can we do with that 8? Don't multiply by that 3. You cannot multiply by that 3. Can you divide both sides by 8? You divide both sides by 8. So I'm going to do that. And that gives me 3 to the x minus 2. All right, now what type of number does that give me? 20 divided by 8 gives you 2.5, right? Or 5 halves. If it gave you like a decimal, don't round it off. You cannot round it off to the very end. But if it gives you a terminating decimal, you can write 2.5. There's no reason you can't. All right, take the log of both sides. Log of 3 to the x minus 2 equals log of 2.5 or log of 5 halves. All right, x minus 2 goes out in front. And you need to treat it and basically put parentheses around it. Okay, because you don't want to view it as not 2 times the log of 3, it is x minus 2 times the log of 3. All right, you got two options here, depending on how you're looking at this. All right, what are you thinking to solve from here? Okay, as you look at this, because there's a couple of different things that will work fine. Right.
Divide by log 2.
All right, divide by log of 3. That's probably the easiest. Okay, probably the easiest. Anybody see something else? No way? No way? All right, we'll divide by log of 3. Divide by log of 3. And now I get x minus 2 equals log of 2.5 divided by log of 3. And now you can add 2. I'm gonna wait to the very end to do any, type it into the calculator. Add 2 to both sides. And so that gives me x equals log of 2.5 divided by log of 3 plus 2. And let's see what we get for that one. See? Got anything?
2.83.
How about 3 decimal places?
2.834.
2.834. All right, we agree? All right, we got a couple head nods. We'll go with that. So that one, yeah.
Because of the change of base formula, could you make the base 3 to make it simpler and then just make the bottom 1 basically? So x equals log base 3 of 2.5 plus 2.
All right, where are you at right here? You right here?
Yes.
Hold on. Where are you going to base 3 at? Right here?
Whenever you use the change of base formula, you divide the log.
Go, so this one right here, so you can make that log, log base 3 of 2.5. Is that what you're saying?
Yeah.
Like in your calculator? Yeah, I mean, that'll be fine, and then divide it by, and then add 2. This is what you're saying?
Yeah.
Yeah, that's the same, equivalent. So in terms, and then you could also go back to, if you looked at this one here, that's where the change of base formula would be applied to, because that would be the log base 4 of 100. Okay, same idea. Okay, if you wanted to do that. And let's see here. I'm just going to erase that. All right, now take a look at this one here. Whoops, I'm going to label this number 5. All right, this one has this one's a little rough. 4 to the 2x plus 1 equals 3 to the x minus 2. All right, there's no numbers out in front. There's nothing to divide by. So what can we immediately do? You got to immediately take log of both sides. So I'm going to have the log of 4 to the 2x plus 1 equals the log of 3 to the x minus 2. Now you can do natural log as well. I said that earlier. So that doesn't matter. All right, where do I go from here? What happens to that 2x plus 1? Goes out in front. What happens to the x minus 2? Goes out in front. Now, after this, you got to be careful here. 2x plus 1 log of 4 equals x minus 2 times log of 3. All right, stop, look at it. Where can we go from here? What can we do? Ryan, you're usually good for a response.
You divide the right side of 3. You divide by log base 4 and x minus 2. Right? set the left side equal to 2x plus 1 over x minus 2 and the right side log 3 over log 4.
I'm not sure where that's going. Don't write this down yet. I'm not gonna say it doesn't work. I need to look at it a little bit more. So basically you're saying, this is what you're saying, 2x plus 1, because I divide by x minus 2, right?
Yeah.
And then log of 3 divided by log of 4. Okay?
Yeah.
Where are you going from there?
Solve the right side, like type in your calculator,
Okay?
and after that.
Okay. I just wanted to make sure, just check where you were going. All right, well, what do we got the issue? Because I got an X here and I got an X here, right? That's where we got an issue at, and we really can't solve that. That would give you a number, and then you would have to multiply back over here by X minus 2 and distribute that and go from there. I think you could get there. But I think it's going to be too messy because you got to get that number, or you're going to leave that. All right. Any other options? Jacob.
Could you set it to 0 and so that like you would a quadratic function sort of?
We can't set it to 0, but it wouldn't be a quadratic. We wouldn't factor it. But we still got to get all the x's by somehow. All right, here's the key thing. Then maybe this will help. This log of 4 is just like a number. It's like a 2. Distribute it inside those parentheses. Okay. The log of 3 is a number. Distribute it inside those parentheses. Basically, that we got to get that x out of the parentheses so that we can move it. Right now, it's kind of stuck in there. Now, when I multiply by log of 4, it gives me 2x log of 4 plus 1 times log of 4, which is just log of 4, equals x times log of 3 minus, minus 2 log of 3. Now, go back to good old algebra 1. What do you do to solve for an equation? You got to get every term with an x on one side and every term without an x on the other. So those two terms are highlighted, have an x. The other two do not. So you need to move them. So in doing that, that gives me, all right, I'm going to subtract x log of 3. So I already have 2x log of 4 minus x log of 3 equals negative 2 log of 3 minus log of 4. And from there, you got two terms with an x, right? Remember what we do? Factor out that x. Factor the x out. Okay? And so this now becomes x 2 log of 4 minus log of 3 equals negative 2 log of 3 minus log of 4. Now divide by 2 log of 4 minus log of 3. Divide that whole thing by 2 log of 4 minus log of 3. All right, use your calculator. Make sure you put that whole numerator in parentheses. Make sure you put the whole denominator in parentheses. Once you get to this point, it's just a calculator entry. Let's see if we match up. Nathan, you can give me the first answer.
Not quite there.
That's all right. We'll wait.
Might be a second.
Okay. Oh, wait. Is that what you got? Yeah.
Yes.
Cole disagrees with you.
Oh, well, it could be because I have a different thing than you do. But,
So I'm wrong.
I have it reversed.
You have it reversed.
Yes, I do.
Is it like 484?
Is it? Well, I don't know. That's why we're trying to find this out. 0.484. We'll go. We'll see. Anybody else? You got an answer? Libby, you got something back there?
I got -2.141.
That's what I got.
Ryan, what'd you get?
Hang on. Yeah, -2.14.
Oh, well, I think it comes out.
Well, I missed a negative.
Anybody got something? Nathan?
The same thing as that.
The
Like
second
the
one?
-2.
Nathan, they're not being very nice to you right now.
Oh, right.
So, all right, I do believe it is -2.141. Now you got to double check what you did wrong. Okay, see if we can figure that out. All right, now, all right, this is the approximate answer. You're not done with this problem. Sorry. We rounded that off. Okay, you are going to take this piece right here and you are going to give me the exact answer. Now, here's what I mean by that. You're going to simplify this as much as possible. Let me give you an idea where you're headed. It's going to be the log of a single number or single fraction on top, like, I don't know, log of 1/3 over the log of a single number or single fraction on bottom. So you got to use your log properties to simplify both of those. So I want it as exact in the exact form as reduced as possible. So what we have to do, or what you have to do, is you got to take -2 log of 3 minus log of 4 and simplify that to the log of a single fraction for a single constant. Now, how do we do that? What do I do with that -2? Negative what?
Like a square thing, like the little number. I forget what it's called.
Called an exponent.
Yeah.
Called an exponent. But okay, we make it one of those little thingies. It goes above a bigger thingy. We'll call it an exponent. So that's the log of 3 to the -2 power minus the log of 4. I'm just going to work with this one. All right, what's the 3 to the little thingy? 3 to the negative seconds, what? 1/9. Don't give me any decimals. Don't give me any decimals. So this is the log of 1/9 minus the log of 4. And so what do I do with this case here? When we got a subtraction, what do we actually do? Divide. So it's the log of 1/9 divided by 4. Can you leave that? Absolutely not, because it's a complex fraction. What is 1/9 divided by 4 the same as? That's a good question. 1/9 divided by 4 is 1/9 times 1/4, right? So what's it become? 1/36. So that equals the log of 1/36. Okay, so now that's the log of 1/36 over, all right, well, what's the 2 log of 4 minus log of 3 going to become? Whew. So that's going to be the log of 4 squared minus the log of 3, which is 16 divided by 3, right? So it says I got the log of 16/3. Now, if I put that in my calculator, what better I get? Log 136 divided by log 16/3. Negative 2.141. Okay, so got to match up. And Buzz, I want you to list me the exact value as well. So you're going to list both, even though the book may not tell you. And it's only for these, like these ones right here. All right, so there's a lot going on there. We're not going to get to that one today. All right, page 484, page 472, some half-life stuff, some solving equations using logs. Good stuff here.
No, we have 3 minutes.